So the question actually says solid sodium and iron 3 oxide are involved in a reaction that is one of many reactions responsible for inflation of the car airbag. So we have the equation, which is 6 sodium plus Fe2 3, giving us 3 sodium hydroxide, sodium oxide. Then we also have plus 2 iron. So they're saying if 100 grams of sodium and 100 grams of iron 3 oxide are used, determine the limiting reactant. Secondly, they're saying moles excess reactant. 3, they're saying mass of solid iron produced. 4, they're saying mass of excess reactant left over. And 5, they're saying what is the percentage used if 58.8 grams of solid iron were produced. Okay, so how do we identify, or maybe how do we determine the so-called limiting reactant? We've been given that this one is having a mass of 100 grams, even this one is also having a mass of 100 grams. So for us to determine what is a limiting reactant, first of all, we need to find the number of what? The number of moles for this and the number of moles for that. But when finding the number of moles for the reaction which is balanced with a given number of moles as coefficient from each side, we don't consider this as what? Part of our calculations when it comes to finding the number of moles. So we know that the mass for this one on a periodic table is what? It's supposed to be 22.99 grams. Meaning that if I want to find the number of moles for sodium, I'll say moles for sodium, this is going to be equal to what? You say 100 over 22.99. Meaning that number of moles for sodium will be equal to we're going to get 4.35 moles. Then we go to iron 3 oxide. How do you find the number of moles based on iron 3 oxide? We understand that the molar mass for this one can be found as follows. We say Fe2O3. So we're going to do like this. I say 3 multiplied by 16. And this one will be 2 multiplied by 5, 5.85. Meaning that the total number of mass for this one will be 159.7, that is grams per mole. So you can also find the number of moles for this one by saying moles for iron 3 oxide is going to be equal to, what is the mass given? 100 over 159.7. Then the number of moles in this case has been found as 0.626 moles. Okay, so basically this one shows that this is the number of moles for sodium, that is the number of moles available. That one is the number of moles for iron 3 oxide available. Now what are we supposed to do for us to know the number of moles that is needed for each? So for us to have the number of moles that is going to be needed for this one, we're going to use, for this one, even that one, we're going to use what we call mole ratio. Remember, we're dealing with the reactants, eh? So these reactants, they are given their ratio as what? 6 to 1. So suppose I want to find the number of moles for this one, meaning that I'm going to use the number to the ratio. Then I have to put the number of moles for this one if I want to find the number of moles for sodium that will be needed. What I mean is I'll put X here, then I'll use the number of moles for that one, which is 0.626 moles. So meaning that the number of moles for sodium that is going to be produced will be 6 multiplied by 0.626. This one is going to give us this one is going to give us 3.76 moles. Same applies if you want to find the number of moles for this one that is going to be produced. I'll use these ones as what? the number of moles available for sodium. But still, I have to use the same what? Mole ratio by saying 6 to 1. So remember, I'm going to use this one and put X where there is part of iron 3 oxide. So this is going to be 4.35 in X. So this is going to be X is going to be equal to 4.35. 4.35, divide this by what? By 6. We find that X is going to be equal to 0.725 moles. So this is a number of moles for iron 3 oxide that is going to be produced. Then these ones a number of sodium that is going to be produced. So I'll write a table to indicate how supposed to identify the limiting reactant and even also the reactant in excess. So I'll do like this. Also do like this. Then here I'll say substance. So here I'll write the number of moles available, moles needed. So to identify which one is the limiting reactant, we need to make sure that the one that is going to produce a huge amount of number as compared to the number of moles available is a limiting reactant, and the one that is having a bigger number of moles available as compared to what is produced is what we call a reactant in excess. So here I put a substance. Okay, so meaning that here we have to put what? Sodium, and there iron 3. Okay. So the number of moles for sodium that is available, I think, remember we found the number of moles as 4.35. I'll write it here. 4.35. Then the number of moles for this one, which is iron 3 oxide that is available, is what? 0.626 moles. So 0.626 moles. Then the number of moles for sodium that is going to be produced is what? 3.76. So 3.76 moles. Then for this one, the number of moles for iron 3 oxide that is going to be produced, we found it as 0.725. So this one, we are getting its number of moles as 0.7 0.7 what? 0.725. So these are the number of moles for each that is going to be needed, and these ones available. So if you compare, this one is producing less amount of number of moles, hence it can't be a limiting reactant. Then this one produces a number of moles as compared to what is available. Hence, iron 3 oxide qualifies to be our limiting reactant. Like this, qualifies to be our limiting reactant. The second question, remember, we are saying it said moles excess reactant. Moles excess reactant. So you go to the one which is in excess. What are the number of moles that are available for the reactant? Is what? 4.35 moles. That's all. Then you go to mass of solid ion produced. How can you find the number of the mass of ion that is going to be produced? So for you to know which reactant you are going to use, or to find the number of moles of ion, basically you need to compare it with what is going to be what. I mean, you have to compare the limiting reactant and the one which is going to be produced. So in this case, you find that this is number 3. We have iron 3 oxide. Whenever you compare this with the iron, you find that this one is having a number of, this one initially it is having a coefficient of 1 as the number of what? Moles. Then this one is having a 2. So just comparing like this, you find that if you want to use more ratios, you're going to say 1 to 1. So 1 to 2. This one is for 2, this one is for 1. Now, for you to find the number of moles produced for this one, I'm going to use the number of moles that is what available for iron free oxide. Hence, we are going to get the mass produced. Once we change the number of moles that we are going to get here, if you put x, say, and you use that one, which is 0.626. So if you multiply, you find that if you say x multiplied by 1, you're going to get x, and equal to 2 multiplied by 6, sorry, 0.626. So x is going to be equal to, so we are getting 1.252 moles. So these are the number of moles that is going to be produced for what? For iron as a solid. For me to find the number of mass that is going to be produced for iron, I have to do what? I have to say moles has to be equal to mass. We divide this by what? By molar mass. Remember, we're dealing with iron. So each number of moles we are from finding as what? 1.252 equate this to mass. You divide. What is the molar mass of iron? If you go on the periodic table, you find that we are finding the number of moles for, the molar mass for iron as what? As 5.85. Then for you to get the number of mass, you just multiply this by that, this by the 1. So say mass is going to be equal to 69.92 grams. These are the grams for iron that are going to be produced, or rather this is the mass of iron that is going to be produced. Then you are done with the third question. You go to the fourth question whereby they are saying the mass of excess reactant left over. So for you to find the number of the mass of excess reactant left over, what you have to do, you need to subtract this number of moles that were initially reacting with the other, which is this and that, by of you subtract this from that one. Then the number of moles that is going to be remaining, you have to do what? You need now to convert it to what? To convert it to the mass based on the so-called sodium which is given here. Meaning that the fourth question is going to be repeated like this. Mass, sorry, first of all, say moles left over. You have to say this has to be equal to the number of moles available minus moles needed for what? For a reactant in excess. So we'll say 4.35 minus 3.76. What number of moles are we getting? Okay. So the number of moles that we are getting number of moles as 0.59 moles. So this is the number of moles that we are left over. So for me to find the so-called mass, I need to multiply this, or rather to use the formula to say moles will be equal to mass over molar mass. Then this is going to be calculated as, where there is moles, you put 0.59, equate this to mass. So you divide this by what? I'm going to divide this by the number of mass for, or molar mass of sodium, which is 22.99, meaning that mass will be equal to, if you multiply this by that, we are getting the number as 1.3, sorry, it's supposed to be 13.5. Write it down here. Mass has to be equal to 13.56 grams. This is the mass that is going to be left over at the end of the reaction. Okay, so now to get what we call, what is the percentage yield if 58.8 of solid iron were produced. The same 58.8 grams of iron, that is our actual yield. Remember the formula for percentage yield has to be equal to actual yield, actual divided by what? Theoretical multiplied by 100%. So what you do, since we've been given the actual yield already, For us to find the number of maybe the so-called theoretical unit actual unit which has been given already, we have to use the reactant which is in what? Which is emitting reactant. I feel like this is the same process we are from doing, because here we use the emitting reactant by using the mole ratio. We found that we converted this to what? The number of mass. So this one in this case applies to be our what? Theoretical yield. Then what we are going to do, we have this which is 58.8. Then this one 69.92. Remember, always actual yield must be less than the theoretical yield. So percentage yield is going to be equal to 58.8. You divide this by 69.92. You multiply everything by 100%. So if you divide 58.8 divided by 69.92, we are getting 0.84096. You multiply this by 100, definitely the answer is going to be 84.1%. And the question is over. Thank you.